Okay, previously we showed you how to drive the ring and clear the residue, and we've got the mark down to the 3-inch depth, so we've already done that. So now I'm going to show you how to go ahead and remove that ring, and we do need to be a little bit careful. The other thing is to make sure, because we're measuring unit of volume, the weight per unit of volume. So I want to make sure that I've driven it evenly, so I'm right at 2 inches all the way around the edge, so my ring isn't crooked. And then we're simply, to do this, we're going to go ahead and have to excavate around the ring. And what we want to do is try to keep all the soil in that volume, which is 3 inches of depth for this particular and it's a 3-inch diameter. So we're going to go ahead and excavate it. Now that we've excavated around the edge of the ring, I want to make sure to get my trowel. In some cases I've seen people use a tile spade as well underneath the ring. We don't want to lose any soil. Okay. So when we do this, we also need to be careful that we cover the top so we don't lose any soil from the top. Okay. Okay. And then so we have the exact amount we need. We have in your bucket, or you can get this out of your kitchen drawer, a knife. And we want to go even to the bottom of the ring, like that. Okay. So we're going to go ahead and make sure to have something underneath the bottom so I don't lose any of my soil. Then I pick up a clean Ziploc bag. Go ahead and we're going to put the soil again into the bag. So the importance here is that we get the exact volume of soil. So if we lose some of the soil, we may have to redo this. So we want to be pretty close to exact to that 3-inch mark, as well as the diameter of the ring. Then I can use the knife to go ahead and make sure all the soil cleans out. Some cases you might use the same ring you use for infiltration. So now I've went ahead and got everything in the Ziploc bag. I go ahead and close it, and you want to label it. In this case, this is the compacted row or wheel traffic row. And then you go to the next part of the field and collect it as well, and then we're ready to go to the lab. Now we just got back from the field, and we have our sample that we pulled from the bag. And we have Virginia Jen with ARS, Research Soil Scientist, is going to help us through step 6 through 11 in the guide. So the first thing we're going to do is go ahead and weigh our sample bag and record its weight in table 2 with the soil in. The next step is to go ahead and weigh an identical clean empty bag and record that in table 2. Next step is to go ahead and weigh an empty microwavable, in this case we're using a tray, if you have a cup, something that's microwave safe, and then record its weight in table 2. Okay. And then the next step is to go ahead and take our sample bag. We're going to mix the sample thoroughly by kneading it with your fingers. You can tell Virginia's done this quite a bit. Okay. And then we're going to take our 1/8 ounce level scoop of the loose soil that's not packed down but struck off level at the top, okay, and then place it in the tray. And we're going to go ahead and weigh that moist subsample before drying it, okay. So now, and then record that. Now we're ready to go ahead and place the tray with the soil in the microwave. We're going to place the tray containing this subsample, and we're going to dry it for at least 2 4-minute cycles at medium power. Now we've went through our first 4-minute cycle. We're going to go ahead and weigh the subsample. Okay. Now after our first cycle, we're going to go ahead and record that on some notes, and we're going to go ahead and dry it through one more 4-minute cycle. Okay, now we've just got through our second 4-minute drying cycle at medium power. We're going to weigh it and compare it. In this case, we changed moisture just a little bit, so we're going to have to go through a third cycle. Okay, we've just completed our third drying cycle, and we're going to compare it to the weight that we recorded from our second cycle. In this case, it's weighing exactly the same at 153 grams. So we're going to go ahead and record that weight in Table 2 in column F. Okay, now that we've got a dry weight of the soil plus the tray, we're going to go ahead and finish our calculations following the example. In this case, we go ahead and go through the example. We're going to take the dry weight of the soil minus the weight of the moist soil minus the dry weight of the soil divided by the dry weight, and that gives us the grams of water per gram of soil. And then we run through the bulk density calculations basically all the way through to where you determine the grams per cubic centimeter squared. Once we've done that, completed those calculations, we're going to go on to Table 3, and we're going to use the same information that we recorded off of Table 2 or determined. We're going to determine soil water content, so we take the soil water content by weight from Table 2 in grams per gram. We take the bulk density we recorded, which is 1.2 grams per cubic centimeters, and then determine using the formula, the volumetric water content. And then from that, we take the volumetric water content times 12 inches of soil depth, so we can get the soil water content in inches per foot. After that step, Table 3, we're going to go on to Table 4 and determine soil porosity. And again, soil porosity, we talked about that earlier. So we take the grams per cubic centimeter, the bulk density. We run through the calculation of 1 minus soil bulk density divided by 2.65, which is the density of rock. And then we get a soil porosity. In this example, it's 54.7% pore space, which is pretty good. Ideal soil would have 50% or more pore space. Next, we're going to determine soil water filled pore space, and taking the volumetric water that we determined from Table 3, and then the soil porosity that we determined from Table 4 in decimal, 0.547 in your example, and determines volumetric water content, which is divided by soil porosity times 100 to give us a soil water filled pore space. So from that, you've determined quite a few things: our porosity, soil water content, soil water filled pore space, to determine if we've got an ideal situation for microbial activity. Our bulk density determination, we would compare that back to the ideal bulk density that you'd have for your soil texture. And also in the table it lists, if you have a bulk density, at what level would it impact root growth. So you want to do that with your students and drive home the importance of bulk density tied to compaction, tied to all the important soil functions and processes that occur.